Welcome to Paideia classes. I hope you are doing well. If you find this video helpful, please like, share, subscribe, and don't forget to press the bell icon for updates on new content. So in our previous two videos on subsets, we have discussed in detail what subsets are, explored real-life examples of subsets, and covered the concept of proper subset along with some examples. Today, we'll be diving deeper into subsets as we solve more examples from your CBSE Class 11 textbook. So let's get started. Before we start the example, I want to mention one more set, which is Singleton set. What does Singleton set means? Single. From the name only, you can tell it is something about a single thing, right? So Singleton set is basically a set which has only one element. Empty set was the set that does not contain any element. So if a set does not contain any element or contains zero element, so that set will be empty. And if a set contains a single element, then that set will be, we call that set a singleton element. Now, example of this set, anything. It could be 1, it could be 2, it could be A, it could be B, it could be pen, anything. Any set which has one single element, that we call as a singleton set. Okay, so let's start the example. In these examples, we have given the sets, empty sets, the sets A, 1, 3, and B, 1, 5, 9. C is given as 1, 3, 5, 7, 9. Insert the symbol subset or not subset is a subset of, so if it is written A subset of B, so we read it as A is a subset of B. And if it is written like this, we read it as A is not a subset of B. Not a. Okay, this symbol, this is what this symbol is. Okay. So we simply need to fill in the blanks, and basically we need to tell the relation between the pair of sets that is given. Okay. So let's see. The first pair is 5 and B. B is 1, 5, 9. Now it does not matter what is written here. We already know that is a subset of every set. Okay. So since empty set is a subset of every set, it is also a subset of B. So here the answer is 5 is a subset of B. Now let's see the next part. We need to find if A is a subset of B or if A is not a subset of B. So to see if A is a subset of B, we simply need to see that if every element of A is also an element of B or not. Now, here 1 belongs to A, right? So let's solve it here. 1 belongs to A and 1 also belongs to B. So we are good here. Then 3 belongs to A, but 3 does not belong. 3 does not belongs to B, and that is why A is not a subset of B. Now let's see the third pair. We need to check between A and C. Okay. Now 1 belongs to A. Okay. Let me just erase this part. 1 belongs to A and 1 also belongs to C. 3 belongs to A and 3 also belongs to C. So therefore, every element of A is also an element of B, and that is why we can say that A is a subset of C. Now let's see the fourth pair, which is B and C. Okay. Now let's see for B and C. So B have 3 elements, 1, 5, 9. 1 belongs to B, 5 belongs to B, and 9 belongs to B. We need to check for these 3. And we can see that 1 belongs to C, 5 belongs to C, and 9 belongs to C. Here, 1 is in the C, 5 is in the C, and 9 is also in the C. And therefore, B is a subset of C. Okay. So, you don't need to write it like this. I just wrote it to get you understand better. We can just simply see here 1 and 3 are in A, and 1 is here, but 3 is not in the B, so A is not a subset of B. And then 1, 3 are in A, and 1, 3 are also in C, so A is a subset of C. And then 1, 5, 9 belongs to B, and 1, 5, 9 also belongs to C, and therefore B is also a subset of C. You just need to do it like this. Let's see the next example. So next is example 10. So we have given a set A. We have given a set A as A, E, I, O. Now we know very well this set. This is the set of all vowel in English. So A is given as A, E, I, O, U, and B is given as simply A, B, C, and D. Now the question is the question is in 3 parts. The first part, they ask, is A a subset of B? Okay, so let's see. A belongs to A belongs to B, E belongs to A, but E does not belongs to B, right? So since E belongs to A, but E does not belongs to B, so just one element is enough. Since E belongs to A but E does not belongs to B, this means that every element of A is not an element of B, and therefore A is not a subset of B. So it covers both. No, so it's not a subset. And why? Why? Because every element of A is not an element of B. Okay, so this covers the first part. Now let's see the second. Is B a subset of A? And if no, why? Okay, so let's see for B also. A belongs to B, A belongs to A. So it's good to go. Now B belongs to B, but B does not belong to A. We are just for to check if a set is a subset of the other set or not, we need to check for every element. But even if there is one element that does not satisfy the condition, we can simply say, okay, the set is not a subset of the other set, because we need to, every element of the set should be in the other element. Okay. So since B belongs to B, but B does not belongs to A. Again, this means that every element of B every element of B is not an element of A. Therefore, B is this covers if no then one. Why? Because every element of B is not an element of A. Let's see the next example. Let A, B, and C be three sets. A belongs to B, okay, and B is a subset of C. Is it true that A is also a subset of C? If not, give an example. Okay. So let's understand the language. A, B, and C are three sets. Okay. Now, what does this mean? A belongs to B. So suppose you have A as 1. Okay. A belongs to B means A should be here, right? A should be here and B could be anything then 2, 3, 4 and even 1 also, 5. So what does this mean? This means that we will write B as this. 1, 2, 3, 4, 5. So this means that A belongs to B does not mean that 1 belongs to B. It means that A as a set belongs to B. Okay. So that is why this here, the element of A is what? 1. 1 is the element of A. But here, this set 1 is the element of B. Okay. And it does not matter if you put 1 here or not. Okay. If you want, you can put it. If you don't want, you cannot. You do not. It does not matter. So A belongs to B means A belongs to B as a set in B. Okay, not as an element 1 in B. Now they are saying that B is a subset of C. B is a subset of C. Okay. So let's take 1, 2, 3, 4, 5 and let's take one more. Some other elements. Okay. They are asking if, so this is our C. They are asking if A is a subset of C or not. A is a subset of C or not. So, A will be a subset of C. When will this happen? If 1 belongs to A, then 1 should also belongs to here, but not this one, right? So, as I told you earlier, it does not matter if you put your 1 here or not. Now, let's take another example. Okay. Let's take another example. So, in this example, A is a subset of B because 1 belongs to A and 1 belongs to A and 1 also belongs to C. 1 belongs to A. 1 is an element of A and 1 is an element of C. So, in this example, A is a subset of C. But let's take a look at another example. Let's write it side by side. So, suppose your A is this again, simply 1, and your B is this. So, what is the condition? If A belongs to B, meaning this should be in B. Now, you can take other element, whatever, right? So, let's take this as 2, 3, 4, 5. Now, we are not taking this 1. It does not matter if we take it or not because we simply needed to take this A or this 1 as a set. Then it is given that B is a subset of C. Now this satisfies this condition that A belongs to B. Let's satisfy this condition. B is a subset of C. So let's take our C as 1, 2, 3, 4, 5. Okay. Now let's take C as 6, 7. Okay, what if we did not take 1 as an element in the C? It still satisfies both of these conditions. A is a subset of B and B is a subset. A belongs to B and B is a subset of C. So here we can see that 1 belongs to A, but 1 does not belong to C because this one is a set, not an element. 1 is an element of A, but 1 is not an element of C, and therefore A is not a subset of C. Okay, so this cover is not given example. This is the example. This example beautifully illustrates the difference between these two signs, belongs to and subset. So if you have A is equal to 1, 2, 3, this means that 1 belongs to A, 2 belongs to A, 3 belongs to A. If you have 1, 2, 3, 4, it means 1 belongs to B, 2 belongs to B, 3 belongs to B, 4 belongs to B. And this also means that A is a subset of, right? But this does not mean that A belongs to B. Why? Because A is a set, not an element. If you take B as 1, 2, 3, and then 4, now here this set A is an element of B. Here set A is an element of B. Okay. So here we can say that A belongs to B. We can also write it as A4 because A is present here as an element, not as an set. Hope this helps. And we will stop our lecture here. Thank you for watching. In the next part, we'll cover the subsets of sets of real number and discuss interval as subsets of R, the real number, the real line. Don't forget to like, share, and subscribe, and hit the bell icon to stay updated. And again, if you have any query, please ask them in comment section. I'll happy to help you. So, okay, see you in the next video.